Hello friends, welcome to Control System Lectures. I am Dr. Nitisha Shrivastava. In this lecture, we will take up one practice question based on Nyquist plot. In this question, we will understand how to draw a polar plot, how to draw an inverse polar plot, how to find the gain margin, phase margin, gain crossover frequency, phase crossover frequency, and also consider the encirclements in the GH plane to apply the Nyquist stability criterion. So, this example is by itself a complete example, which will also let us assess the relative stability of the system. The given open loop transfer function, so Nyquist plot is polar plot, inverse polar plot and Nyquist counter. So, the given open loop transfer function is 1 upon s into 1 plus 2 s into 1 plus s. So, to draw the Nyquist plot, we need to first sketch the polar plot. To sketch the polar plot, we simply put s is equal to j omega, we put s is equal to j omega in the GSHS transfer function. So, this is 1 upon j omega, 1 plus 2 j omega, 1 plus j omega is g j omega h j omega. And the next step is to find the magnitude and angle. So, we have to find the magnitude and angle of g j omega h j omega. So, magnitude is found out by j omega is nothing but 0 plus j omega. So, it is 0 plus omega square root of 1 plus 2 omega the whole square, that is 4 omega square root of 1 plus omega square. So, this is the magnitude of the given transfer function. And what is the phase angle? Phase angle is, this is 0 plus j omega. So, since we are writing it in the numerator, it will be minus tan inverse omega upon 0, which is nothing but minus 90 degree, because angle is written as, if we have a complex value x plus j y, then the angle is minus tan inverse imaginary upon the real value. So, this is minus tan inverse, since again writing in the numerator, minus tan inverse 2 omega upon 1, that is tan inverse 2 omega minus tan inverse omega upon 1. So, this is the magnitude and this is the phase angle, magnitude and phase angle of the given transfer function. Now, to find the end points, before sketching the polar plot, we have to look at where the plot starts at omega equal to 0 and ends at omega is equal to infinity. So, we simply put omega is equal to 0 in the magnitude, and we get the magnitude as, since we have one omega term in the denominator. So, this is nothing but 1 upon omega root of 1 plus omega 4 omega square into root of 1 plus omega square. Since we have one omega term in the denominator, therefore, the magnitude is infinite at omega equal to 0 and the phase angle will be minus 90 degree. So, this is 0 degree, minus 90 degree, minus 180 degree, and this is minus 270 degree. That means, the plot is starting at infinite at omega equal to 0 and at minus 90 degree. Now, if we put omega as infinite, this is to find the end points. When omega is infinite, because we have a omega term in the denominator, magnitude will be 0. And what about the phase angle? Tan inverse infinity is 90 degree, tan inverse infinity is 90 degree. So, it sums out to be minus 270 degree at omega equal to infinity. So, the plot will start at minus 90 degree and terminate at this value, that is, this is omega is equal to infinity at the minus 270 degree axis, whereas the magnitude is 0. Now, next step is to, we can see here that the plot is starting at minus 90 degree and terminating at minus 270 degree here. That means, the plot is not intersecting the imaginary axis, and where the plot intersects the real axis can be found out by rationalize and equate the imaginary part to 0 to find the intersection of the plot with the real axis. So, this is the given transfer function in the form of g j omega h j omega. We rationalize the given transfer function and separate the real and imaginary parts, and to find the intersection with the real axis, that means this plot has intersected the real axis here. So, what is the value at that point? What is the magnitude at that point? So, first we will find at what frequency it has the intersection at what frequency. So, equating the imaginary part to 0, we get that omega is 1 upon root 2. Alternatively, we also understand that this is the negative real axis, and at this point the when the polar plot is intersecting the negative real axis, the phase angle is minus 90 degree. Therefore, the alternate method to find out the frequency is, we simply take up the phi, that is the phase angle equation. This is our phase angle equation, phase angle phi. This phase angle equation we have equated it to minus 180 degree, and solving this we get omega as same 1 upon root 2. So, either you can do this way to find the frequency at which the polar plot cross the real axis, or you can equate the phase angle to minus 180 degree. Now, what is the magnitude at omega equal to 1 upon root 2? Now, what is this is known as the phase, basically this is the phase crossover frequency. And what is the magnitude at phase crossover frequency? We are substituting, this is the magnitude equation, this is the magnitude equation. We are substituting omega as 1 by root 2 and found that magnitude is 0.66. That means, the magnitude when the polar plot is cross the real axis, intersecting the real axis, is 0.66. And here we can see that this is the polar plot and this is 0 and this is minus 1 and this point is 0.66. So, that means that the minus 1 plus j 0 point is not enclosed. And what is the gain margin? 1.5, and gain margin in decibels is minus 20 log A, that is A for us is 0.666 and it comes out to be 3.521 dB. That means, the gain margin is positive and the system is stable like this, and as we had studied that this is A and A here is 0.66 and it is not encircling the minus 1 plus j 0 part, because that unit radius circle is, this is the margin still left. Now, to find the phase margin, this is the gain margin. To find the phase margin is obtained when the polar plot crosses the unity radius circle, intersects with the unity radius circle, that is when the magnitude of g j omega h j omega is 1. So, we have taken the magnitude equation and simply equated it to 1. This is the magnitude equation. This magnitude equation is equated to 1, because at that time the here this value of the polar plot, and this value of the polar plot, this omega is equal to, substituting or equating this value to 1, we get that 4 omega raised to 6 plus 5 omega raised to 4 plus omega square is equal to 1. So, this is a 6th order equation. So, simplifying it or manipulating, we simply use omega square as x and solve. When we find that, when we solve this, we find these values of omega, these values of x. That means, omega, this is the value of frequency we are considering, because these are no imaginary frequencies, and the value to be taken for omega is 0.57, and this omega is the gain crossover frequency, because the magnitude at this time is 1. At this frequency the magnitude is 1. So, this is known as the gain crossover frequency. Now, we need to find the phase margin. That means, we have to substitute this value of omega, that is gain crossover frequency, in the phase equation, phase angle equation. So, we simply substitute omega here and find that the phase angle is minus 168.51 degrees. So, the polar plot what we had drawn. So, this is the unit radius circle, and this is the phase angle obtained. This phase angle is 168.51 degrees. It is minus. So, measuring from the positive real axis in this direction, it is 168.51 degrees. So, this is the phase margin. This phi m is the phase margin, and phase margin is given by phi plus 180 degree, which is coming out to be 11.48 degrees. So, the phase margin is positive, and therefore, the system is stable. We obtain gain margin also a positive value, and also the phase margin as a positive value. So, what is the polar plot here? This is the polar plot, and also understood about the phase margin and gain margin. Now, we need to complete the Nyquist plot. So, if this is the polar plot obtained, then what is the inverse polar plot? This is coming from omega equal to infinity. So, inverse polar plot is this, in this direction. So, this completes the polar plot and inverse polar plot. Now, we need to look at the Nyquist contour. This is omega equal to infinity. Now, to map the, since in this given transfer function we have one pole at the origin, therefore, the contour has to be indented at the origin, and there are no poles on the j omega axis. So, we need to consider the contour which is indented at the origin. The contour which is covering the complete right half S plane is how it is mapped in the GH plane, by substituting S with a limit r tends to infinity r e raised to j theta, and this contour is travelling from plus 90 degree to minus 90 degree. This is nothing but j minus j infinity, this is plus j infinity. It is a infinite radius circle. Now, to map this part of the contour in the S plane, we have to simply substitute, in place of S we are writing r e raised to j theta, r e raised to j theta, and here in place of S r e raised to j theta, 1 plus 2 S, 1 plus 2 r e raised to j theta, 1 plus r e raised to j theta. We have now in place of S we have written this r e raised to j theta. Now, here limit r tends to infinity. When limit r tends to infinity, it is simply 1 upon, this is 2 r, taking this outside, this will come out to be, this is 2 r, and this is also, this will be r cube, and this is e raised to minus e raised to 3 j theta, and since 1 upon, here the terms will become 1, and for this term will become 1, because we are applying limit r tends to infinity. Now, here substituting this limit r tends to infinity, because this r is in the denominator, we will get the magnitude as 0, and the angle when taken the numerator e raised to minus 3 j theta. So, this is how this right half S plane contour is mapped into a GH plane with 0 magnitude and the angle e raised to minus j theta, here it is plus 90 degree to minus 90 degree. So, we will get 0 magnitude with the angle travelling from minus 270 degree to 0 degree to plus 270 degree. It means that the right half S plane is mapped into GH plane with a 0 magnitude. Since the magnitude is 0, the angle is irrelevant, that is the infinite radius semicircle which was a contour in the right half S plane is mapped into 0 magnitude. So, this is the polar plot and the inverse polar plot, and this mapping is simply the 0 magnitude. Now, we have one pole at the origin. So, this infinitesimal small semicircle is mapped as G p e raised to j theta, p e raised to j theta. We are just replacing s with this value and putting the limit s p tends to 0, because it is a very small radius circle, 0 almost 0 radius circle, and we can find that the magnitude is infinite. The mapping of this intended by contour is having a magnitude infinite, and the angle is, because if you simply replace 0 here, we get 1 divided by p e raised to j theta by applying the limit. So, 1 upon 0 is infinite magnitude and e raised to minus j theta. This contour is in the S plane travelling from minus 90 to plus 90 in the counter clockwise direction. So, this is mapped in GH plane as infinite magnitude contour, which is travelling from plus 90, because this is a minus sign here, plus 90 to 0 degree to minus 90 degree. That means, how do we map this? The Nyquist contour, which is indented to bypass the origin, is mapped into a infinite magnitude semicircle, that is from plus 90 to minus 90. So, this is the minus 90 degree and this is plus 90 degree. So, it is mapped into this contour completes like this in the it is mapped in this direction, it is mapped in this direction, and this is because travelling like this and inverse polar plot, and the circle completes like this, and we can see that this point was 0.66, that means minus 1 plus j 0 is not encircled by the contour in the GH plane. Therefore, it means that this is completed. It means that the number of poles of GSHs in the right half S plane for the given open loop transfer function is 0, because one pole is at the origin and the remaining 2 poles are in the left half S plane. Therefore, the number of poles of GSHs in the right half S plane is 0. Therefore, P is 0, and we can see that when we map the infinite semicircle in the S plane and also the contour which was indented at the origin, we found that there are no encirclements in the GH plane of the minus 1 plus j 0 point. Therefore, n is 0. So, the system is closed loop stable because the value of z is 0. So, this system is open loop stable as well as closed loop stable. So, this practice question covered how to draw a polar plot, the steps involved to draw a polar plot, to find the gain margin, phase margin, gain crossover frequency, phase crossover frequency, and also to understand the encirclements by considering the contour in the S plane. Thank you.